Once a virtual implant treatment plan has been finalized, we can proceed with surgical guide design. We will click on the Guide Design module, and the first step is to ensure that we eliminate any undercuts in our STL that could create an issue when it comes to the surgical guide fit. Before proceeding with that step, we will first want to verify that the correct STL file has been selected that we want to proceed with our surgical design on. Once verified, we will go ahead and rotate the model to where we're able to view the occlusal plane and click Set Insert Direction from View. Once rotating the model, the dark regions represent undercuts that the software has detected based on the occlusal view that we specified. This step is very important as the dark regions is where the blockout material will be applied in order to fill in those undercuts. If you are planning on milling rather than printing a surgical guide, you can see that there are milling parameters for you to manipulate as well. Once we click Generate Undercut, a blockout model will be created where all the undercuts have now been filled in with vertical material. We can also differentiate between the two visually by utilizing the color difference feature. In freeform modeling, we have some tools to allow finer editing of the model if there are still areas of concern. Each tool has a diameter and strength setting. The diameter changes the area that your tool will affect with each click, while the strength changes the intensity in which the effects are applied to the model with each click. As a shortcut, you're able to hold Control and scroll the mouse wheel in order to adjust the strength, while holding Shift and scrolling the mouse wheel will adjust the diameter. In this example, we can go ahead and fill in some material in these interproximal spaces that may cause problems with the surgical guide fit. When we are satisfied with the model, we can click on Next Step. In this step, we will begin left-clicking in order to specify the desired coverage of our surgical guide. This will be a tooth-supported guide, so we will make sure to encompass the incisal and occlusal surfaces as we work through the model. As you can see, we're not running into any undercuts due to the blockout we applied previously. We're also able to edit our boundary at any point by clicking and dragging the points directly. These are the parameters in which the surgical guide will be generated, so it is very important to make sure these settings are consistent with your particular printer and resin prior to design. We can click Create Guide, and the software will proceed with generating the surgical guide body. As you can see, presently there are not any sleeve holes in the surgical guide as we need to proceed with some post-processing first. As always, we are able to visually turn objects on and off. You can see as well as that the software will not allow us to add any material to the integral surface of the surgical guide, since the software recognizes that that action will impair the fit of the surgical guide. Once the guide has been evaluated for any necessary edits, we can proceed with adding inspection windows. Inspection windows are particularly important in a tooth-supported guide as it allows the surgeon to visually confirm the surgical guide is fully seated prior to conducting the surgery. The windows generally should be added on the buccal aspect for ease in viewing and should be added throughout the arch to ensure that the guide can be confirmed that it's fully seated. The final step will be to add the patient name to the surgical guide. You are able to either engrave or emboss the patient name and click Next Step to finalize the design. During this finalization step, the software will conduct a Boolean operation to add in the holes to accommodate the surgical sleeves. If we hide the planned sleeves, we can observe that the sleeve holes in the surgical guide have been created, as well as our inspection windows and patient name.